athletic ability whatsoever, but it's okay. All right, today we're going to learn about signs of trig functions. Today's lesson is like the precursor. So let me give you an example. You're going to have to know when I say how to find the sine of 300, you need to know what the sine of 300 is right now without using your calculator. Go.
40.
You have to. So today's lesson leads into the learning of that, but there's a little bit of like information beforehand that we need to kind of clarify and lead up to. So first thing is this understanding of signs in particular quadrants. So if I have my coordinate grid, here's my axes. In the first quadrant, all of your trig functions, if you were to draw your right triangles, all of them would be positive. So we're going to use this mnemonic device, A for all. All of them are positive. Makes sense. They're all in quadrant 1. They should be positive. In the second quadrant, the only things that are positive in this quadrant, the only trig ratios that are quadrant out of the 6 of them, the sine, cosine, tangent, cotangent, cosecant, secant, the only ones that are positive are the ones that begin with S, which is sine, and then its reciprocal, cosecant. So I guess I shouldn't say, yeah, well, the S stands for the sine, and then you do its reciprocal, cosecant. The mnemonic device we say here is students. All students. And these are the 2 that are positive. In this third quadrant here, the only trig functions that are positive the first one starts with a T, which is, we all know, tan, and its reciprocal, cotangent. So we say all students take. And then the last one, is a C, which is cosine and secant. Always goes back to that, doesn't it? We say all students take calculus. Now, yes, of theta, if the terminal side contains the point 5, -12. Evaluate the 6 trig functions of theta if the terminal side contains the point 5, -12. And you'll have 3 questions like this for homework tonight. It's not that hard. The first thing you want to do is draw the triangle in the right quadrant. So we're going to find the point 5, -12. 1, 2, 3, 4, 5. You don't have to be this accurate. 6, 7, 8, 9, 10. You can just do.
Bless you.
Thank you. You don't have to be this accurate. You can just actually draw your, put your point right there, like put it right here and then call it 5, 12. But when you draw the right triangle, listen to me, okay? You need to make sure you draw the triangle correctly or else it's going to all be wrong. You are drawing the triangle from here to here is going to be the hypotenuse, and you always, always, always connect it to the x-axis. That's where you draw your right triangle. Do not connect it to the y. You will have completely different sine and cosine. Always, always, always draw your point, connect to the x-axis. So if you have to write that down, number 2, connect to the x-axis. This angle right up here, not that little guy, that's your theta, okay? So we now are going to label our triangle. This side is how many again? 5. And then we went down 12, which is -12. This is a very famous Pythagorean triple. 5, 12, what? 13. Glad you're all so famous about it. So this is going to be 13. Is it positive or -13?
Negative.
Oh, I know we always do this. Write this down. Whoops. Hypotenuse is always positive. It's never, ever going to be negative. The hypotenuse is always going to be positive.
How can a length be negative anyway?
Because it's the position of where you are on the quadrant. You are down in the 4th quadrant, so that's why. Okay? Once you've drawn these, now you can evaluate your 6 trig functions, meaning I can then say, okay, sine of theta, if I'm standing here, my sine would be what over what? Negative 12 over 13. This is what you had your quiz on, except without negatives. Cosine would be adjacent over hypotenuse, so 513. Tan would be opposite over adjacent, so negative 12 over 5. And then you reciprocate. So cosecant, 13 over negative 12. Secant, 13 over 5. Cotangent, 5 over negative 12. Do you notice something? What are the only 2 ones that are positive? Cosine and secant. And that's because what quadrant am I in right now? All students take calculus. Okay? So that's why calculus, cosine, these are the only 2 that are supposed to be positive. Everything else is negative. So that's where we get that little mnemonic device from. Does that make sense to you all? All right. So you'll have that to do. Then the second part of the lesson today is this idea of reference angles. All right, everybody got this down? Sorry.
John, what the heck? You know you were thinking it.
Okay, by definition, reference angles are the acute, underline the word acute, angle formed by the terminal side of theta and the x-axis. The acute, what do we know about acute angles? They have to be less than 90 and bigger than 0. So they must be between 0 and 90. And they must be positive, by the way. They're not negative. Reference angles are not negative, and they're acute. Okay? Reference angles are pretty easy to find degree-wise. The problem will be when we do the radians, which I have a separate sheet for you in a minute. What I want you to do right now is this is what the book does. I know a lot of teachers do this. I'm going to make you draw this anyway, but I tell you, I don't even do this. I don't memorize this. If you draw your triangle in quadrant 1, your triangle connected to the x-axis would look like this. If I said, what are the reference angles in quadrant 1? They would just be whatever 0 to 90 degree is, right? Because aren't all of them acute in this quadrant? But then when you start heading this way, this angle that's formed right there, even though I connect it to the x-axis, it's this angle right here, is actually 150 degrees, right? But this angle right in here would be the reference angle. And what would be the reference angle? Well, how close am I to this line right here, to this x-axis? That's what this is saying. How close am I there? Well, I would just do 180 minus whatever the angle is that I'm finding in that quadrant. So if this is 150, my reference angle would be 30. 180 minus 150, 30. If I'm down in this quadrant, again, I would start over here on this part. This is where my initial side would be. I'd go all the way around. I could possibly be at, 225. But my reference angle would be that angle right in there. How far am I away from the x-axis? Well, I'm really 45 degrees away. How do I know? Well, what did I just do? I just did my angle minus 180. Last but not least, if I go over in this quadrant, their quadrant in here is between 270 and 360. All of these numbers are closer to the x-axis by 360. So you would do 360 minus theta. Now, I know I can already see on all of your faces, you're like, I don't get it, Ms. Seta. I don't get it. Here's the trick. You only have to determine if the angle is closer to 180 or if it's closer to 360 and by how much. That's what a reference angle is. So, for example, if I said, find a reference angle of 160 degrees, are you closer to 180 or are you closer to 360? 180, by how much? That's your reference angle. Boom. Let me do it again. What's the reference angle to 210 degrees? Are you closer to 180? Or are you closer to 360?
180.
By how much? Is this making sense now? Okay. What's the reference angle to 300 degrees? Are you closer to 180 or 360?
360.
360 by 60 degrees. What if I said, what's the reference angle of 610 degrees? What do I have to do now?
You have to
Find a coterminal. So take away 360 in your head. And you're at, now I always try to go between 0 and 360. That's what I do. So I'm at, what is that, 250? Is 250 closer to 360 or is 250 closer to 180? And by how much? 180 by 70 degrees. Just real quick, what if I had given you a reference angle of negative 45? Guess what the acute reference angle would be? What would be the reference angle to negative 45? 45. You just change it to positive. If this is already acute, just change it to positive. Okay? Now, I gave you a little worksheet. Bear with me. This will be really quick and easy. I want you to just do, on this worksheet, 1 through 12. Ignore this. Just do 1 through 12. We'll worry about the radians in a minute. Just do 1 through 12. Find a reference angle to 150. Are you closer to 180 or 360? Closer to 180 or 360? If you're already... Just stop at 12. We'll do this side in a minute. Okay? Let's try a few of these. What's number 2? 70. Okay? 3, I got to take away a 360 because I got to make it between 0 and 360. So I have, what is that, 120? So then what would be my reference to that? 60. It's closer to 180. 370, I take away, or add a 360, I'm at negative 10, but you know what? That's acute, so I'm just going to change it to positive, 10 degrees. That's my reference angle.
Oh, so you still have to change it.
Yeah, it has to be positive. 190, closer to 180 or closer to 360?
10.
By 10, you're closer to 180. 80, isn't that already acute? Done. What's this one? 30. 460, take away a 360, you're at 100. So are you closer to 180, you closer to 360? 180 by, that's your reference. Negative 200, so you add 360, what is that, 160? And 160 is closer to 180 by 20 degrees. Closer to 180 by 5. Closer to 360 by 20. Do one more. Negative 275, add 360 and you're at 85?
Yeah.
Done. That's it. That's what a reference angle is. You're going to find out why that's important because you always have to refer. And to be honest with you, your reference angles, the only ones we truly use in degrees are 45, 30, 60. We don't really use any other ones than that. A 30, 60, and a 45. Those are usually our reference angles. Why did they make us do ones like 70? Just to make sure you know what the definition is. Now, how do we do it if it's in radians? Flippy, flippy. Okay. You are looking at our unit circle, which we will get to in a minute. Just don't freak out on me. There's a reason. There's methods to Mrs. Setta's madness. Okay. I have taken the coordinate plane. This is your y-axis, and then this is your x-axis. And I've cut it into radians. This is 0 radian. This is pi. 0 is always here. Pi is always here. I've actually cut it up, the circle, into equal pieces on top. How many equal pieces do you see on top? 4. So up here, I want you all to write this. This is pi over 4. This is 2 pi over 4. But Mrs. Setta, that's pi over 2. I know. Just write 2 pi over 4, precious one. 3 pi over 4. Pi is equivalent to 4 pi over 4. 5 pi over 4, go all the way around. 6 pi over 4, 7 pi over 4, and then 8 pi over 4, which is equivalent to 2 pi's. We're going to do another one. You're going to see why in a minute. I have reasons. This is my y-axis. This is my x. Notice I put a dash here because I really didn't cut it. I cut it into thirds. So this is pi over 3. 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, whoops, 6 pi over 3, which is equivalent to 2 pi. You always want to go around the circle, 2 pi. What did I do on this third circle here? What did I cut the top into, just the top part? 6's. Pi over 6, 2 pi over 6, but Mrs. Seta, that's pi over 3. Just write it. 3 pi over 6, but that's pi over 2. Correct, just write it. 4 pi over 6, 5 pi over 6, 6 pi over 6. Keep going. Every year I do this, it's because students have problems with fractions. If you knew your fractions, this will be very easy for you. A lot of kids don't know their fractions. Last but not least, this one is in eighths. So this is pi over 8, 2 pi over 8, which is equivalent to pi over 4, and keep going. 3 pi over 8. Should always have a 1 on this side and a 2 pi that reduces on this side. Oi, 12 pi over 8, 13 pi over 8. There's a reason for this. We're going to find reference angles to the ones in radians, but we also need to know what quadrant they're in. When we start learning what the next lesson we learn is called exact trig values, you need to know what quadrant it's in, or else we're going to mess up stuff. So that's why I've drawn these beautiful circles for you. So let's start at this one right here. Name the quadrant each angle lies in and its reference angle. So if I have 3 pi over 4, look at your pi over 4, 3 pi over 4. What quadrant are you in? 3 pi over 4. Quadrant 2. What would be the reference angle? How far is 3 pi over 4 from the x-axis? How far? What is it? 1/4 pi or pi over 4. Aren't you 1 pi over 4 away from here? Okay, so write that down. Pi over 4. Let's do another one. Negative 7 pi over 3. Okay, go to the pi over 3. If I'm negative, that means I go this way, right? So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 pi over 3 is actually 5 pi over 3. What quadrant am I in? Quadrant 4. How far is this guy away from the x-axis? How far? 1 pi over 3. Interesting. Let's do another one. 5 pi over 6, quadrant 2. How far away is that from the x-axis? Pi over 6. Are we finding anything here that's going on yet? No? Let's do another one. Negative 17 pi. Okay, so going around once would be negative 12, negative 13, negative 14, negative 15, negative 16, negative 17 is equivalent to 7 pi. That's in quadrant 3. How far are you away? Pi over 6. Wait, hold the phone. Pi over 4, pi over 3, pi over 6, pi over 6. Do you notice anything? You're always what?
Pi over.
Pi over whatever that denominator is. If the denominator is 4, pi over 4. If your denominator is 3, pi over 3. If the denominator is 8, pi over 6. Now here's the only thing. This one changes. 8 does. But I'll be honest with you, we never use 8s. Never. But we're going to do it here just to make the people happy. Negative 3 pi is equivalent to 1, 2, 3. How far are you away from the x-axis? How many pi's? Positive 3 pi. You're in quadrant 4, sorry. But don't even worry about telling me what quadrant it is. What is your reference angle to negative pi over 4? What would the reference angle be? Pi over 4. What would the reference angle be to 2 pi over 3? Pi over 3. What would the reference angle be to 11 pi over 6? Are you ready? Pi over 6. The 8s you never really use, but they're on here. So flip it back over. I bet you could do all these now, except don't even really, honestly, don't worry about the 5 ones down here. Don't even fill this out. Just tell me what the reference angle to number 13 is. What's this one? What's this one? What's this one? Okay, now pi's over 2, there is not a reference angle. It's actually landing on a quadrant. We're going to talk about that in a minute. So it's really not applicable to reference angles. But so here's the point. Take out the other sheet, which is for homework tonight. Where's my other sheet? And we're almost done. Okay, go to 13.3. Okay, so these first 3 questions, you have to draw the point and then make your triangles. That's pretty easy. You can do that. Okay. These next 4 questions right here, you find the reference angle. So if it's in degree, you say, am I closer to 180 or 360? By how much? But if it's in radians, like this one, what would be the reference angle to negative 7 pi over 4? You would say, you're brilliant. 13 pi over 8, I hate that this book does it, but because we never use 8s. We never in trig use 8s, but it is 3 pi over 8. If you noticed, all the 8s are always 3 pi over 8. Okay? Really? I don't know.
Y'all get ready to fight.
Oh. Hi, thank you.
Oh, yeah, that's.
You got so mad.
Because I was like,
Get ready to
really?
fight, boys.
Come on. So sweet. All right. Last but not least, I'm actually going to do one of your homework problems. So your homework tonight is 1, 2, 3, 4, 5, 6, 7, and then 16 and 17, but I'm going to do number 17 for you. Here's why. Well, first of all, before I go on, do you understand reference angles now? Reference angles are, if it's in degrees, it's closer to 180 or 360. If it's a pi over something, that's your reference angle. Pi over 3, pi over 3. 2 pi over 3, still pi over 3. 5 pi over 3, still pi over 3. You with me? All right, good. We got this. All right, number 17. You are to draw the angle in standard position, given the quadrant, find the function, find the exact 5 remaining trigonometric functions. So let me draw this for you because I'm going to tell you this one's wrong. Isn't that great? I'm so glad I give you worksheets that are wrong. Here we go.
They make so many mistakes.
I know. So if I draw quadrant 3, you go like this, you draw your little line, connect to the x-axis, put a right triangle there, and a right angle, and then put theta. Okay? If I'm standing right here, sine is what over what? Opposite over hypotenuse. So this side opposite would be 2, and the hypotenuse would be 3. What is my problem right now? 2 should be negative. Boo, you idiots.
Boo.
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 So that's why it's wrong. And if you think about it, all students take sine is negative inside of this one. Okay. You would use Pythagorean theorem to figure out this one, and I'll even give it to you. I think it's square root 5. Yeah. And it's not just square root 5. If you're going this way on the x-axis, it's actually what?
Negative.
Oh, got to put that there. So now you can tell me what the cosine of theta is, the tan of theta is, and all the reciprocals. Well, I might as well just get it down here. The cosecant, secant, and cotangent. So if I'm standing here at cosine would be adjacent over hypotenuse. So what would I write? Negative root 5 over 3. Tangent would be opposite over adjacent. And notice what happens. A negative over negative is positive, and tan is positive in quadrant 3. But you would have to rationalize that. So I believe it's 2 root 5 over 5. And then cosecant is the flip of sine. So that'd be negative 3 over 2. And then obviously you can fill out the rest. All right, so that's it today. That's all we learned. We learned that we now have to deal with these negatives, and we learned how to find reference angles. And the next time I see you, you will know how to find the sine of 225 without a calculator. And you'll be like, oh, Mr. Risley knows that trick. It's not a trick, y'all. You're going to know the trick.
Does he actually though?
Yeah, if you ask him what sine 225 is, he knows what sine 225 is.
I'll call him right now.
Maybe he just memorized
You do it, honey. He did memorize it, as you all will, all of you.